Welcome to this podcast episode brought to you by AGS Agriculture Global Solutions, your partner for better oil palm farming.
Thank you. It is great to be here today to talk about this.
Today we're focusing on a really exciting low-tech way to fix rock-hard soil, use up your farm waste, and directly boost your monthly profits.
It's a huge issue. Yeah.
But before we jump into that, remember to register now on cropdrive.ai. Use the tool completely free of charge, no hidden fees, no conditions. CropDrive helps you improve your oil palm growing skills.
Highly recommend checking that out.
And be sure to subscribe to our channel so you do not miss key oil palm best practice episodes. So let's get right into it. As an advisor for smallholder farmers, you see the realities on the ground every day.
Oh, absolutely. I mean, every single week I'm out there talking to farmers and, one of the biggest complaints I hear is about the soil.
Right. Especially that really tough compacted soil.
Exactly. A lot of farmers, especially in tropical regions, are working with what's called ultisol. It's a very specific type of dirt that makes up about 25% of Indonesia's landmass, for example.
Which is what, like tens of millions of hectares?
Yeah, nearly 46 million hectares just in Indonesia. And naturally, it's just terrible for farming.
Terrible how? Like just no nutrients.
Well, yeah, it has incredibly low organic carbon. But the bigger issue is the physical structure. It's packed so tightly together that it basically acts like concrete.
Wow, like a concrete sponge.
Right, but a sponge that won't actually absorb anything. When the heavy tropical rains come, the water can't soak into the ground. It just, sheets right across the surface.
And I imagine that just washes away all the expensive fertilizers the farmers just applied.
Exactly. And that is straight up lost money. Yeah. You buy fertilizer to feed your palms, and the rain just flushes it right into the nearest river.
So you're losing money on fertilizer, and you're probably causing some local flooding too.
Yeah, that surface runoff is a major cause of sudden flooding. But then it creates a double disaster because, a few months later when the dry season hits...
the trees have no water reserved in the ground.
Exactly. The soil didn't trap any of that rain when it had the chance, so the palms get drought stressed and your yields drop.
Which means your monthly profit takes a massive hit.
Right. And to add to all this, you've got this other huge problem on the farm, which is the waste.
Oh, yeah. The empty fruit bunches, all those pruned leaves.
Right. Millions of tough, woody leaves. It piles up. So you have these two massive headaches, rock-hard soil that ruins your yields, and mountains of waste that you don't know what to do with.
Which sounds like a nightmare for a smallholder farmer just trying to make a living.
It really is. But that brings us to this fascinating study from 2025 out of Jambi University in Indonesia.
Right. The researchers there looked at this exact problem.
Yeah. They wanted to see if they could use the waste problem to fix the soil problem. And they do it without any expensive chemicals or heavy machinery.
That's the best part for our listeners, right?
Yeah.
Because heavy machinery is just out of the question for most smallholders.
Exactly. It's too expensive and it damages the roots of your palms anyway. So, the scientists tested a really simple method called biopores.
Biopores. So what exactly is a biopore for the farmers listening right now?
It's literally just a hole in the ground.
Wait, just a hole?
Just a hole. They went into a 4-year-old oil palm plantation, and they used a simple manual auger like a hand drill for the dirt to dig vertical holes straight down into that hard soil around the trees.
Okay, how deep are we talking?
Exactly 100 centimeters deep, so about a meter.
Right, so they're punching these meter-deep holes through that hard, crusty topsoil.
Yeah, it's almost like acupuncture for the earth. You're creating these direct drainage pipes so the heavy rain can bypass the hard surface and instantly get down deep into the ground.
Okay, that makes sense for draining the water, but I mean, wouldn't an empty hole in bad soil just wash out and collapse on itself the second it rains?
Mm-hmm. You hit the nail on the head, that's the catch. If you leave it empty, it's useless. The mud just washes inward and seals it right back up.
So what do?
They stuffed the holes with the farm waste.
Ah, okay, so they chopped up all those empty fruit bunches and leaves and packed them in.
Exactly. They turned these drainage holes into tiny underground compost bins.
That's brilliant. So it physically props the hole open.
Right, it gives it structural support. But more importantly, as the rain flows into the hole, it soaks through all that rotting organic waste.
Making like a nutrient tea.
Exactly. A nutrient tea that seeps outward into the surrounding hard dirt, feeding the soil microbes deep underground.
Okay, so you're changing the soil chemistry from the inside out.
Yeah, and the study showed that you can't just sweep up, any random pile of trash and throw it in the hole.
Really? I would think any organic matter is good organic matter.
Well, it is, but the type of waste determines how fast it rots and feeds the soil. The scientists tested 8 different combinations of waste.
Okay, and what was the winning recipe? Because the farmers listening are going to want to know exactly what to put in these biopores.
The absolute best result was what they called Plot 7. It was a specific 4-part mixture.
All right, what's in the Plot 7 mix?
First, you use Mucuna bracteata, which is that fast-growing, leafy, green cover crop you see on a lot of farms.
Right, very common.
Second, you add the empty palm fruit bunches.
Okay, we've got plenty of those.
Third, you mix in the tough pruned palm leaves.
The really woody ones.
Yeah. And finally, the 4th ingredient is oil palm shell biochar.
Biochar. Just to clarify, that's like charcoal made from the palm kernel shells.
Exactly, yeah. You burn the hard shells in a low oxygen fire to make it. So that 4-part mix, the green crop, the empty bunches, the pruned leaves, and the biochar was the magic bullet.
Why that specific combo, though? What makes it better than just using only leaves or only the fruit bunches?
It comes down to something scientists call the carbon to nitrogen ratio. But to keep it really simple for us in the field, it's just about how fast the microbes in the soil can eat the waste.
Okay, so it's like fast food versus slow food.
Exactly. Microbes need nitrogen to live and eat. The green cover crop, the mucuna, is loaded with easily available nitrogen. It rots super fast.
So it's an immediate energy drink for the soil bugs.
Right. It gives the soil an immediate explosive boost. The microbes multiply like crazy.
Good.
But if you only use the fast green stuff...
We would all rot away in a week, and the hole would just be empty again.
Exactly. That's why you need the pruned palm leaves and the empty fruit bunches. They are extremely tough and woody. They rot very, very slowly.
I see. So they act like a time-release capsule.
That's exactly it. The green stuff kickstarts the system, and the tough leaves keep feeding the massive microbial population month after month.
And what about that 4th ingredient, the biochar? What does that do?
The biochar is amazing because microscopically it's incredibly porous. It's full of tiny holes. It basically acts like an underground apartment building for the microbes.
Oh, wow. So they actually live inside the charcoal.
Yeah. It protects them from predators in extreme dry spells while they slowly eat the tougher waste around them.
That's incredible. So you've got the fast food, the slow food, and the housing all packed into this 100-centimeter hole.
You've got it. And the results they saw from doing this were just staggering.
How fast did they see a change in the soil?
3 months.
Wait, really? Just 90 days to fix that concrete like Ultisol?
Just 90 days. The organic carbon in the soil around these holes increased by over 100%.
That's massive. And what did that do to the hardness of the dirt?
Well, as the microbes eat all this carbon, they basically excrete these natural glues. It clumps the microscopic clay particles together into larger chunks.
Right, which means there's more empty space between the chunks.
Exactly. The researchers found that the porosity, the actual empty space in the dirt for air and water, jumped up to 57%.
So the microbes literally fluffed up the soil from the inside out.
They turned the concrete back into a real sponge, and this completely changed how the farm handled water.
I bet. Because if the soil is fluffier, the rain can actually get in.
Oh, the difference was night and day. Before the biopores, water barely moved through the soil. But in that Plot 7 area, the speed at which the ground could swallow water increased by almost 10 times.
10 times faster. So that heavy tropical rain hits, and instead of washing your fertilizer into the river,
it rushes straight down the biopores and spreads out horizontally through that newly fluffed up dirt. The flood problem is practically solved at the source.
that immediately saves the farmer money on lost inputs.
Absolutely. But here's the best part, and this is what directly impacts a farmer's monthly profit. It's not just about draining the water away.
Right, you want to keep some of it for the dry season.
Exactly. Because the soil was so much fluffier, its ability to actually trap and hold on to water, what they call the available water capacity, more than doubled.
It went up by like 124% or something, right?
Yeah. Over double the water banked underground. So when the rains stop and the dry season hits, those palm roots have this massive reservoir of water to drink from.
Which means they don't get drought stressed.
Right. They keep producing fruit. Stable yields means stable income.
Mm.
You aren't taking a huge financial hit every time there's a dry spell.
This is just brilliant. It's a complete closed-loop system.
It really is.
Hmm.
You're taking the exact waste that used to cost you money to manage or dispose of, and you're using it to fix the exact soil that was killing your yields.
So if I'm a smallholder farmer listening right now and I want to do this, let's walk through the exact steps. How do I apply this today?
Okay, step 1. Gather your materials. Don't burn your pruned leaves or your empty fruit bunches.
Right, keep them on the farm.
Chop them up into smaller pieces. You want a mix of the tough stuff, some green cover crop if you have it, and some biochar if you can make it.
And if they don't have all four, like what if they only have the leaves and the empty bunches?
Even just leaves and empty bunches will help, but try to mix in something green and fast rotting to get the microbes started.
Got it. Step 2.
Step 2, use a manual hand auger. Go near the base of your palm trees, maybe in the natural drainage paths where water usually pools, and dig holes 100 centimeters deep.
About a meter. And how wide should these holes be?
Usually about 10 to 30 centimeters wide, just a standard auger size.
Okay, and step 3 is just stuff them full.
Pack them full of your waste mixture all the way to the top.
Now, I have to ask about the labor here. Digging all these meter-deep holes across your whole farm sounds like a lot of sweating.
It is. I'm not going to sugarcoat it. It requires an upfront investment in your time and labor.
Right, it's hard work.
But you have to look at the math. What is the cost of doing nothing? You're losing expensive fertilizer every time it rains.
And you're losing tons of fruit during the dry season.
Exactly. The labor you put into digging these biopores pays for itself almost immediately by bulletproofing your farm against extreme weather.
It protects your monthly profit.
Yes. But there is one important thing farmers need to remember. This is not a set it and forget it solution.
Oh, right, because the waste in the hole is literally being eaten.
Exactly. Over time, as the microbes eat the waste and turn it into soil, the level inside the biopore will sink.
So the hole will slowly empty out again.
Right. So every few months or after your next harvest, you need to go around and top off the holes with new chopped up waste.
It's an ongoing process. You're constantly feeding the earth.
You have to feed the soil so the soil can feed the crop. It completely changes how you look at farming. It's not just about taking from the land. It's a dynamic relationship.
You know, it's just so inspiring to see that the solution to these massive global agricultural problems isn't always some million-dollar synthetic chemical.
Exactly. Sometimes the cure for the damage an industry causes is literally sitting right there in its own garbage.
Turning trash into a hydrological superpower.
I like to leave farmers with this thought. If a strategically filled hole in the dirt can reverse years of soil damage and secure your monthly income, what other problems on your farm are just waiting for a simple, locally sourced solution?
That is an amazing point to ponder. Look twice at what you're throwing away, because it might be exactly what your farm is starving for.
Exactly. Work with nature, not against it.
Well, this has been an incredibly practical and eye-opening discussion. Thank you so much for breaking down the science into real, actionable advice for the growers out there.
It was my pleasure. Thanks for having me.
Remember to visit our AI farming assistant at cropdrive.ai to learn more on how to increase your oil palm yields and incomes. Thanks for listening.